Algebra 2, Set 6, Equations with Decimal Numbers and Consecutive Integer Word Problems. Okay, so when you have decimal numbers in an equation, it's always helpful to multiply every term by a power of 10. Okay, so solve this equation. 0.003x plus 0.4 is equal to 2.05. So the first thing we look is that and see is that the smallest term is 3/1000 x, and so since it's 3/1000, we're going to multiply every term by 1000. So when we multiply 3/1000 by 1000, we get 3x. Multiply 4/10 by 1000, we get 400. Multiply 2 and 5/100, we get 2050. And now it's a much easier problem to solve. We just subtract 400 from both sides, and then we get 3x is equal to 1650, so x is equal to 550. Okay, now we'll do a word problem. The students found that 15,000ths of the teachers were either brave or completely fearless. If 300 teachers fell into one of these categories, how many teachers were there in all? So the first thing we'll do is we'll write this out. So we know that 15,000ths of all the teachers are fearless, which was 300. So 15,000ths of all are 300. So we'll take that and we'll turn it into an equation. So 15,000ths times x is equal to 300. And then we just, since we have 15,000ths, if we multiply both sides by 1,000, we end up having 15x is equal to 300,000. Then we do that division, 300,000 divided by 15. Well, 15 goes into 30 twice, so it goes into 300,000 20,000 times. So 20,000 teachers were the total number. Okay. An analysis of the old woman's utterances showed that 0.932 were vaticinal. If she spoke 2,000 times during the period in question, how many utterances were not vaticinal? So we have 0.932 that were, so if we subtract that from 1, we will find out that 0.068 of utterances were not. So 68,000ths of the utterances were not. So of means multiply, 0.068 times 2,000 equals how many were not vaticinal. So from here, all we have to do is multiply. We can multiply 1, 2, 3, multiply by 1,000. Since they're on the same side, then we divide this by 1,000. So we end up getting 68 times 2. And when we do 68 times 2, we end up with 136 that were not vaticinal. Okay, now we'll talk about consecutive integers. You've done word problems with consecutive integers that are n, and then the next number would be n plus 1, the next number would be n plus 1, and so on. If we have consecutive even or odd integers, if they're odd, it's n, and then the next one is 2 away, so it's n plus 2. Then the next one is 2 away from that, so that's n plus 4, and so on. The same thing is true for even integers. You have n, n plus 2, n plus 4, and so on. The problems always work out that you have an even or an odd answer. So let's do one. Find 3 consecutive even integers such that 5 times the sum of the first and the third is 16 greater than 9 times the second. So the first thing that stands out, it says find 3 consecutive even integers. So we have n plus 2, and n plus 4. Those are our 3 consecutive integers. We have our first, second, and third one. Now, it says find the integers such that 5 times the sum of the first and the third. So we're looking at the sum, first of all, and we need the sum of the first and the third. So the first is n, and the third is n plus 4. And we need 5 times that. So 5 times the sum of the first and third is 16 greater than 9 times the second. So from here, we just multiply it out. N plus n is 2n. 5 times 2n is 10n. 5 times 4 is 20. That is equal to 9n plus 18 plus 16. We can subtract 9n from both sides and subtract 20 from both sides. We're left with n, which is equal to 14. Now we were looking for 3 consecutive even integers. If 14 is the first, our second one would be 16 and our third one would be 18. Okay, last one. Find 4 consecutive integers such that 5 times the sum of the first and fourth is 1 greater than 8 times the third. So we have 4 consecutive integers, meaning we have n plus 1, n plus 2, and n plus 3. Those are our first, second, third, and fourth. So it says such that 5 times the sum of the first and fourth. So we start with sum again of the first and the fourth. So we have n and n plus 3, and we have 5 times that. 5 times the sum of the first and fourth is 1 greater than 8 times the third. So 8 times the third is 8 times n plus 2. From here, n plus n is 2n, and we'll distribute 5. So 5 times 2n is 10n. 5 times 3 is 15. 8 times n, 8 times 2, plus 1. Now we'll subtract 8n, subtract 15, and we end up with 2n equals 2, so n equals 1. We needed 4 consecutive integers, so our answer is going to be 1, 2, 3, and 4.